So here is my solution for question 5, and the part I'm doing is part A. And what the question is about is I want to turn this DC motor, and I want to simulate the amount of angle I turned from DC motor, and then simulate that in the stepper motor. And what I did is I connect the stepper motor and the DC motor to the motor shield, and I use a to interrupt function from MiniLab 7 to read what is the encoder position from the DC motor, and then I translate that to what's the position for the shaft, and then I calculate what's the angle of the shaft I'm currently at, and then I also record what was my previous angle in the shaft, and then in this way I can calculate a delta angle, and that is amount of angle that need to be turned by the stepper motor. And then I use a constant of 1.8 to translate the amount of angle that need to be turned by the stepper motor to the amount of steps that need to be taken by the stepper motor. And the constant 1.8 means since the stepper motor takes 200 steps to complete one revolution, which means that each step represents 1.8 degrees in angle. And now I'm gonna and also when the angle is positive, the stepper motor turns clockwise, and when the angle is negative, then the stepper motor turns counterclockwise. And now I'm gonna give you a quick demo. So I'm gonna turn the DC motor 180 degree first, clockwise, and then it's gonna be reflected on the stepper motor, and then I'm gonna turn it counterclockwise 180 degree as well. And yeah. Okay, so here is what it does when I turn a 180 degree clockwise, and when I go backward, there we go. Yeah, it goes back. Yeah, I think I turned a little bit more. That's a little bit more than 180 degree, but that's also reflected in the stepper motor. So when I go this way, and when I go this way.